Hello everybody and welcome to another Mystery Box Function Challenge. Today is a Friday, so it's an extra challenging challenge. In this mystery box, there's some challenging math and you get to try to figure it out. Pause the video, click the link in the description, put in as many numbers as you like at the top, see how they come out transformed at the bottom. And when you've got an idea about what's inside the mystery box, come on back and see if I get what you get. All right, let's begin here. I'm going to put in a 0. And 0 gives us 0. How about a 1? Okay, so I've got some long decimal there. You know, when I get these long decimals, I think maybe it's a square root function, maybe it's a trig function. 2. Okay, now I'm thinking trig because it goes up and then down. I suppose it could be some weird parabola. What about a 3? Okay, up, then down, then up. So it looks like there's some kind of repeating pattern here. Let me go in the negative direction. See if we get the same kind of thing. That's not exactly what I expected. Yeah, I mean, -1 gives us the exact same answer that 1 did. What about 2? Yeah, and 2 gives us the same -2 is what I wanted to put in. And -2 gives us the same thing 2 did. So it's like a mirror image. So the reason that's a little confusing to me is because it looks like trig, or I think trig, and I saw that 0 gives us 0, I immediately thought sine. And remember, on the unit circle, what these trig functions do is you put in the angle starting here, and it gives you the coordinates on the outside of the circle. So at an angle of 0, you would be at the point 1, 0, and the x-coordinate is the cosine, and the y-coordinate is the sine. And we've got put in 0, you get a 0 out. That says sine. And then sine starts. Well, it should, let's see, the y-coordinate should go up, and it seems to go up, and then it should go down, and it seems to go down. But in the negative direction, your y-coordinate should be going down, and it's going up. So something's strange there. So it sort of reversed the sign that you would expect on the other side. And not S-I-N-E, but S-I-G-N for sine. Let's put in some values that would make sense for trig functions and see if we can get a better sense of this. I'm going to put in 3.1415, so an approximation of pi. Wow, that is not what I expected. So at pi, sine should be over here. This is pi. Whoops, get my pen. So this is pi, and at pi, sine should be 0, and we're -1/2 or so. And this shape of these dots is looking really strange. Let's try an approximation of pi over 2. So 1.5 is pretty close there. So at pi over 2, I'd expect 1, but I'd expect to be a lot closer to 1 than we actually are there. How interesting. I think the biggest clue I've got so far is that the shape I expected on the left-hand side of the y-axis is sort of a mirror image instead of continuing the pattern. So it like reversed the sign. It's positive where I expected it to be negative. And there are a couple of things that can do that. One would be absolute value. So is this the sign of the absolute value of x? I don't think so, because if I put in something close to pi over 2, I should get something close to 1, and this is not close enough. The other thing that could do that is squaring. So I wonder if that's what's going on. So our function could be, would you square the whole thing? Yeah, I don't think so. So if this was sine of x quantity squared, then at pi over 2, you'd expect 1, because the sine of pi over 2 would be 1. You square that, you get 1. So maybe this is the sine of x squared. Does that pan out with what we're seeing here? So that means this 1.5, if it's something close to pi over 2, that would end up, you'd square that and you'd get pi squared over 4. Oops, pi squared over 4, whatever that's going to be. That could be that. Let's think about this on the other side. So if you put in a negative 1.5, you would just get the same positive value. And I bet we do. I bet we do get that. Let's put in a negative 1.5. Yeah, and we're getting that same value, a positive value. So that is my best guess. What squaring, let me actually write this in a more legible way. So I'm thinking that the function is the sine of x squared. And what that is going to do actually is it's going to make on the x-axis, between 0 and 1 and 0 and negative 1, it's going to look fairly similar to the sine curve, except a mirror image on either side. And then actually these waves should get closer and closer together. So this is going to be a pretty funky looking graph. I'm not 100% sure about this one, but I think we need to just check and see, because we've struggled with this long enough. And if we're wrong, we're wrong. Let's reveal. Okay, so it is the sine of x squared. And let's look at this graph. Look at that. Yeah, very curious. So you get this sort of mirror image. And that was the biggest clue for me, this section right around here. And then the waves get closer and closer and closer together because you're squaring it, and that decreases the phase here, the distance between the troughs. Wow, that was a super toughie. If you didn't get this, no shame on you. Were you suspecting that it was trigonometric? I think if you got that far, that's pretty good, because these points came out pretty messy looking. Let me know how it went. Thanks, everybody.